So we've spoken about carbon dioxide mainly with vegetation, but there are also other trace gases which are important related to vegetation and the biosphere. And the two main ones are methane and nitrous oxide, N2O. And we can see the increases in these gases here on the plots. And it's interesting that the methane is fairly closely linked to the growth of the global population, which we can also see on this plot. So these two greenhouse gases, which are actually much more powerful per molecule relative to carbon dioxide, are also emitted from the surface and are related to the biosphere. The nitrous oxide, the N2O, is related mainly to fertilizers that we use on our agriculture. So fertilizers are rich in nitrogen. When they react with oxygen in the soils, they produce N2O, which is released and acts as a greenhouse gas, trapping in the heat. There are many ways that we produce methane also through the biosphere, and we'll talk about that in a bit, but methane is a much more powerful gas than carbon dioxide in the atmosphere. The production of methane, if we start with methane, and you can see here this schematic diagram from 2008 to 2017. This is a bit complicated, the plot, but it shows us both the man-made sources in red and the natural sources in green. And again, for many of these greenhouse gases, we have both natural and man-made, and it's not always simple to separate them out. Methane is caused in what we call reduced conditions, when we don't have a lot of oxygen, and so we can't oxidize this carbon. And so this is, when we look at in natural environments, this occurs mainly in places like wetlands, or bogs, when we have lots of water, and underground we have organic matter which doesn't oxidize, and therefore we have the release of methane gas. But it also occurs inside the stomachs of animals, cows, sheep, goats. And if we look at the circle in the top, the red and the green numbers here, we have about 3,000 teragrams of methane from anthropogenic sources today, and natural sources are less than that. They're about 2,000 teragrams in the atmosphere. And the main source really for the anthropogenic sources are from oil and gas pipeline leaks, actually. Not on purpose. We have a lot of leaks from the pipeline, and the mining process itself can release methane. And following that, we have from livestock, we mentioned cows, beef, sheep, but also from landfills, all of our garbage which goes to landfills, because again, there's not much oxygen inside. This produces the methane release. And even things like rice farming. There's a lot of rice which is eaten in India and China every day. And the process of growing the rice, which is in water, in a reduced environment, also results in the emission of methane into the atmosphere. So this process of growing vegetation, of agriculture, will result in emission of methane. If we look at the trends in methane, they're not straight or in a straight line like we see with carbon dioxide. There was actually a slowing down in the 2000s, but in recent years, we actually see an acceleration in the rise on methane of about 1% every year. And we know, if we look on the right-hand side, that after carbon dioxide, methane is the strongest and the biggest greenhouse gas which is impacting global warming. So if we want to deal with methane and reduce methane, we have to deal also with vegetation, agriculture, and the biosphere to reduce the amount of greenhouse gases in the atmosphere. As mentioned before, when we spoke about the permafrost, in the permafrost, when it's frozen, we don't have much release of methane, but if this starts to thaw, that we're already seeing the warming temperatures in the high latitudes, the permafrost has a huge amount of methane locked in the frozen grounds under in the deep layers. And as the soil temperatures, the air temperatures start to warm in higher latitudes, especially in the summers, we can expect to see a huge increase in the emissions of methane in the atmosphere. And this could be a huge problem because it can happen in a fairly short period of time. Aerosols are also a major impact, can have a major impact of the climate, and can also come from the biosphere and from vegetation. And the main impact is, after maybe impacting our health, is the impact on clouds. We've spoken about clouds and how the albedo of clouds is affected by the number of particles or the number of cloud condensation nuclei in the clouds. The more particles we have in the cloud, the smaller the droplets, the brighter the clouds, the higher the albedo, and the more sunlight is reflected to space, and the cooler the planet will be. So if we can change through vegetation the changes in the number of particles, aerosols in the atmosphere, this can have a cooling effect and offset global warming. And there are two key processes. The first is actually through the phytoplankton and the biology in the oceans. And there's one key gas called dimethyl sulfide, DMS, which is produced by the phytoplankton and the biological activity in the ocean. This gas is released and goes into the atmosphere, where it can be oxidized with oxygen to produce sulfate aerosols, this SO4 in the diagram. And these particles can, again, these are solid particles, can act as the nuclei for droplets to form. And if we have more of these sulfate particles, the clouds which form around these particles will be brighter, whiter, and can actually cool the climate. We also have direct release of particles from vegetation. If we look at the plot on the right, if we're looking at the land vegetation, we have various organic aerosols. We also have gases which can be released, isoprenes, from plants which can then be converted to aerosols, to particles. And again, these can go into clouds, can affect the cloud droplets, the snow formation, can affect the optical properties of the clouds, and can have an impact on the climate. We spoke about burning of the vegetation. There's a big problem with biomass burning, not only chopping down the vegetation, but burning it. These also produce aerosols. And on the one hand, this is very dangerous for our health. Air quality, we breathe in these particles and they can cause health problems. But again, we can have them impacting clouds and the hydrological cycle, not only the brightness of the clouds, where some particles, depending on their color, if they're black soot particles, can actually absorb sunlight and change the characteristics of clouds. If they're whiter or lighter colors, they can make the clouds brighter, but they can also affect how much rainfall comes out of these clouds. When we have lots and lots of particles from smoke in the clouds, we actually reduce the rainfall, and this can result in other climatic impacts of droughts, which can occur in regions where we have more aerosols from the vegetation, mainly from the fires. So to summarize this effect of the aerosols, the plants can result in different emissions, both gases and particles, the volatile organic compounds, primary aerosols, which can go into clouds in different ways, affecting the cloud droplet, the number of cloud droplets, the formation of ice, the formation of rainfall, the type of rainfall we get. And therefore, this is the link with the climate, because again, the clouds, the amount of clouds that cover the Earth, the brightness of the clouds, these are all going to affect eventually the radiation balance and the temperature at the surface.